this question of what is a decision is something that neuroscientists actually don't agree on. So if you ask me what a decision is, there's many things that are a decision. When your thermostat decides that it's too cold in the room and turns the heat on, that's a decision. Because it's like taking some continuous input and then making a discrete action. When a caterpillar lays an egg on a plant and the plant shoots out a little thing to push the egg off, that's also a decision. But in normal human speech, we usually think of a decision as something that's like a conscious or deliberate decision, like decide what to wear for work or decide what to order for dinner, something that's conscious. But the problem for me is that we don't really know if all animals have consciousness. We think humans have consciousness. It seems like we probably do. And I think probably a mouse has some kind of consciousness. But I don't know if a frog does, but a frog still makes decisions. So if we think of decisions as only conscious, then it creates a problem for studying decision-making in animals. So I generally don't think of decisions as only these kinds of deliberative conscious decisions. I think of decisions as anything where you have a sort of continuous input, and then suddenly that result crosses some threshold, and that results in an action. So from my perspective, that's kind of the definition of a decision. There's a lot of work on this topic, and I think it's obviously both. A decision, as I said, is just like, in a way, an action. An action is the outcome of a decision. And actions can be the result of many things. So if I see a ball flying towards my head, I make a decision to like lift my arm up and block it. That's a very instinctual process, probably very rational. Because you're, protecting yourself. It's also emotional because we feel threatened by something flying towards us. So to me, this like line between emotion and reason, it's clear that there's like different brain areas. There's areas like the amygdala, which seem to be more involved in innate behavior, like behaviors that you get from genetics. So you can take a rat that's been raised in a lab that's never ever seen a cat in its life, never seen a fox in its life, but if you bring a cat near it, it's really afraid. So it didn't learn that fear. That fear was hard-coded in its brain. Okay, so there's those kinds of innate behaviors. Do you want to call those emotional? I guess you could call those emotional, right? And then there's things that are more learned, like, I'm sitting here answering questions. Nothing in evolution prepared me for this event, really, except maybe that I had language and some reasoning faculty, but there's a lot of all the neuroscience facts that I learned, I had to learn them through my life. I didn't get those from evolution. So I guess in one sense I see a spectrum more in terms of flexibility. So we have behaviors that are very flexible, that are context specific, and then we have behaviors which are very innate, very instinctual, and then there is a kind of a trade-off between decisions which are being driven by more instinctual or habitual learning versus more flexible and like strategic kind of learning. Well, it goes back to that issue of this conscious deliberation. So most of our brain processes are unconscious. We don't have access to them. And so we have a decision in front of us and we feel like one decision is right. That feeling is part of our unconscious processing. But then when we deliberate, we use our conscious processing, we say, oh, well, maybe the other thing is right. I personally usually go with my feeling. I think usually that's the more correct one. Usually when you consciously deliberate, it takes you to the wrong decision, I think. So I think we should, at least for myself, I feel like I have good instincts, so I like to trust my instincts rather than worry too much about deliberating and reasoning to the correct choice. Now, if I'm playing chess or something, then maybe I'll focus more on rational decisions. But if you're making an important decision, like whether to move to a new apartment or whether you should date someone or break up with them, I feel like you should trust your feelings. There's some kinds of decisions that in neuroscience we call perceptual decisions, where there is a right answer. Like I show you a shape and I say, is the shape a square or a triangle? Well, it's either a square or a triangle. There's a true answer. But most decisions in real life are economic decisions, where we're deciding between two goods or two offers. And there, as you said, there's no right answer. depending on your own preferences, depending on whether you like, tall ceilings or more windows, or you like quiet, like it could be right for one person and wrong for another person. I've done a lot of research on perceptual decisions where we know what the right answer is. So we've, let's say, trained animals to like listen to some sounds and tell us whether there are more sounds from the right or from the left. And in that case, we've studied some of the brain areas that involved in sort of integrating information over time. And we also know that the animals don't do the task perfectly. They're also kind of biased by sort of their own preferences. Like maybe they like going to the right more than they like going to the left. So even though they're doing the task, they're also mixing in their own bias or their own preference. So I think it very much depends on the context and how well trained you are. And essentially different settings can kind of, and this is what Daniel Kahneman has shown, is that the way you frame a choice has a huge influence on the decision. So if I say, do you want a 50% chance of winning $100 or $50? Okay, so those should be equal, but most people choose $50. But if I change it and I say, well, I'm going to give you $100, now you have a 50% chance of losing $50, or you can just have $50. Then people switch even though it's actually exactly the same. And you can show this even with professional decision makers. So with doctors, if you say, there's a treatment and it's going to save this many lives, they'll make one decision. But if you say, there's a treatment and even with the treatment, this many people will die. But it's the exact same decision, just framed as like a death or versus living, people will switch their choices. So that's a kind of irrationality. And this is well studied. And humans, I think partly because of language, we make a lot of mistakes in our reasoning. This is not my own research. I study animal research mostly. And I mean, recently we started to study this a little bit, but language plays a big role. And there's some really interesting social psychology work on differences in cognitive style in, for example, like China and Korea versus America. And part of it is based on like differences in language. I actually do some AI research in my lab. So there's different AI. One form of AI, which is this like popular deep learning thing, does rely on big data. But there's other forms of AI, like expert systems, which don't necessarily rely on big data, although generally they do use a lot of data for developing these systems. Already, so many important jobs are assisted by AI, like doctors and lawyers. As a doctor, you put in the diagnosis, you put in the symptoms, and from your years of experience what it probably is. But the expert system may catch something that you've never seen before, especially if you work in a place where you don't see that many patients. And so these kinds of AI-assisted decisions are definitely helpful. Same thing with lawyers. Like, if you're a lawyer, you have to know all of the law. It's very hard. But by using AI, it can help search for relevant cases. It's not replacing your decision-making yet, but it's definitely assistive. And as we know, like for games like chess, AI beats humans, and for Go as well. But what most people don't know is that there's a whole field of chess which is like a human plus an AI partnered together. They can actually beat an AI. So the AI helps the human reduce the number of moves that they need to think about to just maybe a few possible good moves, and then the human can select amongst them. And it seems that is actually more effective than just letting the AI play on its own. If you train the AI on biased data, it will have the biases. I mean, I think there's two ways. This is, so one is that being aware of the fact that there's bias in the data set can allow us to correct for those biases. But the thing is, I'm not necessarily advocating that AI make the decision. I'm just advocating that AI can help humans make their decisions. I do think that humans make terrible decisions. Like most of our political leadership is, and I'm not American, but the American system right now is really problematic. And so I think an AI can definitely do better. Humans are very selfish, they're greedy, they're petty, they have ego and pride, and AI doesn't have any of that. So if you write the objective function correctly, you say develop an AI and you say, oh, well, we want to maximize the life expectancy of the people in this country or something, and develop policy for that. Okay, well, then it's very clear like what the objective is. I mean, one great thing about the world is that there's so many countries. So it only takes like one small country to sort of agree to try this as an experiment and see how it goes. So, and not only that, like maybe it won't happen at the level of a country first, maybe it will happen at the level of a city. Instead of having a mayor, they'll have an AI mayor or whatever. So I really think that, well, look, we're already putting our lives in the hands of AI when we go put our Tesla on autopilot or whatever, right? So, and there's a lot of controversy over that, but people are already putting their lives in the hands of AI. And then, autopilots and airplanes, and AI is like all around us. I think, as I said before, obviously there's risks of AI, as you said, like if they're trained on biased data, then they can make mistakes. But I think what will happen is that we'll have AI work with humans together for a while, and then the AI will just become more and more trusted to the point where they're almost operating completely independently. Probably for a long time, there'll still be some humans who can like have the power to like override the AI. The AI says like, do this policy, and the humans can be like, no, that's not great. But I don't know, I think there's a lot of evidence that in democratic countries where there's elections, like the politicians make decisions only based on a few years because they just want to get elected, and then they leave and they don't really care what happens after that. And so an AI that has continuity like may not have that kind of thing and may be able to make longer term decisions. Humans, we all have to find our own meaning in our lives. I mean, I don't think there's any one answer. Like, I'm not really a religious person. Some people think that, there's religious things that give them meaning. To me, meaning just comes from like human interaction, like spending time with my family and friends and stuff like that, or, reading a good book or spending time in nature. So for me, it's okay. So there's psychology, and then there's cognitive science, which is highly overlapping with psychology, and then there's neuroscience, and there's also cognitive neuroscience. So all of these things are kind of overlapping. It's not like this is psychology and this is neuroscience. There's like a shared thing. If you want to be a neuroscientist, you have to either record or perturb the brain. Whereas psychology, you only have to really engage with behavior. And then in cognitive science, it's like you're modeling cognition, but without measuring brain or perturbing brain activity. So it's a subtle difference, but I think in my mind, there's a clear difference between someone who's doing just psychology and just neuroscience. Now this becomes a bit blurry with, as you said, functional brain imaging. So you can take someone who, for their whole scientific career, just studied behavior. Maybe they gave some pen and paper tests. Then they said, okay, let's put those people, the students, into the brain scanner. And now we're going to measure brain activity while people are doing this test. Does that make someone a neuroscientist? I guess, but I think the kinds of questions that these people are generally asking are not that sophisticated. Sometimes I see headlines like, self-confidence found in the brain. And I'm like, where else did you think it was going to be? All behavior is in the brain. It's not a discovery to say that like some behavior is in the brain. That's just the fact of biology. So in order to really like say something more interesting, you have to, let's say, have a theory about how some set of pattern of brain activity leads to a behavior. And there is good work doing that, but all these studies that are basically just like, oh, we found this in the brain. It's like, that's not very interesting to me. So this question of like, should psychology be threatened by neuroscience? I think it is threatened from a funding perspective, but I think it's a mistake because I think that we don't understand behavior well enough. Like most of the things that neuroscience is studying are very simple behaviors. Like, for example, we were studying, are there more sounds on the right versus the left? This very simple perceptual decision. It's nothing like the kind of complex decisions that people make in their day-to-day lives. People often confuse the difference between the brain and the mind. So the brain is that thing in your head, that wet thing in your head. The mind is like the phenomena of your experience, right? It's like, so to me, if you want to study the brain, you have to study neuroscience. But if you want to study the mind, you can study cognitive science. There's an important difference between simulating the brain and simulating the mind. In order to simulate the brain, we would have to simulate DNA and proteins and ions and fluid dynamics and the physical processes. Like a full brain simulation is just impossible. Like I don't think there's enough computation in the universe to do a full brain simulation. But a simulation of the mind is much simpler because then we only have to emulate the behavior of the mind and not all of the details. To me, cognitive science actually is very important right now. And I think partly because of artificial intelligence and companies like DeepMind, there's actually a renaissance in cognitive science, which I think is really good. And so I think there maybe is like a shift from old psychology to cognitive science. And actually, I think there was just a review article in Nature, or an opinion piece, basically arguing that we need a new cognitive science of machines. So we need people with cognitive science training to actually study AI, study like deep nets to understand how they think. Because as you said, if we're going to depend on AI to make important decisions for us, we better understand how they think. And those skills of understanding how things think, those are the skills of cognitive science and neuroscience. There's several lines of research in my lab. The work that I'm going to talk about today is this work that links chronic stress to decision making. And to me, this is a really important social question because the discussion around poverty is very political. A lot of people feel like people are poor because they're bad people, they make bad decisions, and they deserve it. They're lazy, they blah, blah, blah. A lot of people think so. But I think the evidence is building that, especially, there's a few flaws in that reasoning. One is that children are blameless, right? Children aren't born bad. They're innocent, but they're born into poverty, and then they lack nutrition, and they lack education, and then they end up maybe making bad decisions. But it's only because they didn't have the proper resources. And so part of what this set of work is trying to do is to basically show that even animals, if you can take mice that are essentially identical to each other, and you place one set of mice under chronic stress, and they shift their decisions to be bad decisions. So if chronic stress can make any animal make bad decisions, then surely one can understand that the chronic stress of living in poverty can also lead people to make bad decisions. And it's not because they're bad people, but it's because of their situation, because of the environment. And so this work is really kind of focused on that. Now that's only the first step, and then once we've established this phenomena, then we can go and actually understand the changes in the brain and maybe try to develop some policies. Like, let's say we stress a group of mice, but we provide them with more exercise or extra enrichment or a different diet or a different kind of social engagement. Maybe that can help balance the effects of stress, or even develop certain drugs or something that would balance the effects. So, of course, the real solution is to bring people out of poverty, but that's going to take time. So in the meantime, if we can help sort of mitigate the effects of this stress on decision-making, I think that has a lot of social value. So in the last 10 years, the technology has just become so amazing that I'm constantly surprised by like the new tools that we have. But that's not really the question. So I think for me, the biggest shift that I had in the way I think about the brain is that it's very easy for us. We all know about the reflex, right? Like you hit your knee and you kick your leg. And for probably 100 years, this idea of the reflex and that like behavior is basically like building up reflexes to be more complex, and that the way behavior happens is that there's some input in the world and it sets off like a chain reaction and then you get some behavior. This idea was popularized by people like Pavlov and Sherrington and other behaviorists like Skinner. And I think that idea is just wrong. And especially for parts of the brain like the frontal cortex and the prefrontal cortex, they're not like that at all. The evidence that we have now from recordings, from monkeys and from rats, is that the way the brain works, especially the frontal cortex, it's more like this like chaotic vortex of activity. And that when you get an input, it just changes things just a little bit, almost imperceptibly, like a very small change in the dynamics of this vortex. And that's enough to generate behavior and a decision. It's not like sometimes the way we like to think of the brain, it's like, oh, the train is going down the tracks, then you throw a switch, like, should the train go this way, this way? That's just the wrong analogy. And I think there's a whole generation of neuroscientists my age and older that kind of learned that like train on the tracks and each decision is like a switch. And I think in a way we're really suffering because of that, because that's not how the brain works. The brain is this super complicated dynamical system with all this feedback, and the math and the kind of education you need to understand the brain is the math of linear algebra and differential equations and things like that, like very high-dimensional, nonlinear dynamics. Like fluid dynamics is like a good kind of analogy in a way. And so I think that we need to shift people's thinking about how the brain works from this very kind of train track switching view to this more dynamic view, especially training the next generation of neuroscientists. I mean, it's very clear that that is how the brain works. But so I think that's the biggest shift, probably in the way I think about the brain. That was kind of surprised me, I said.